Hi students, in this session we are going to discuss about the important carbon compounds, that is ethanol and acetic acid are also called ethanoic acid. In this session we are going to learn about some properties, how they react, ethanol react with base or whatever it is, just a reaction of ethanol, then esterification reaction for ethanoic acid, then soap and detergents also we are going to learn in this session. Now, some important carbon compounds, that is, here we are going to discuss about the ethanol and the ethanoic acid. First, we will discuss the properties of ethanol. That is, ethanol means ethyl alcohol, or simply we can tell alcohol. So, ethanol is a liquid at room temperature, and the ethanol is commonly called as what? Alcohol, and is a active ingredient of all alcoholic drink also. So, in addition, because it is a good solvent also, it is used as a medicine such as tincture of iodine, cough syrup and many tonics. See, ethanol is also soluble in water in all proportion. Why mean? They forms a hydrogen bonds in water. Then the consumption of ethanol, so that is small quantity of dilute ethanol, causes drunkenness. That is why even though this practice is condemned, that is it's socially widespread practice, so that intake of small quantity of pure ethanol, that is absolute alcohol, can be lethal. That is long-term consumption of alcohol deaths, that is health, it causes a health problem. Now, properties of the ethanol. First, when ethanol react with the sodium metal to produce sodium ethoxide and hydrogen. See, the hydrogen gas is evolved and the sodium ethoxide. The sodium ethoxide is a polar compound. See, the sodium metal react with ethanol. Suppose react with water means violent, but here react with alcohol to produce the sodium ethoxide. Here, the alcohols usually reacting with the sodium, that is leading to the evaluation of the hydrogen gas. When react with water also, it produce hydrogen gas. When react with ethanol also, it produce hydrogen gas. See, then the next reaction is ethanol treatment with the hot concentrated sulfuric acid to produce the ethene. Ethanol, alcohol, simply alcohols are converts to alkene. The alcohols are easily converts to alkene. This having some three-step mechanism. This reaction involving three-step mechanism that you are going to learn in higher classes. See here, generally hydration of alcohol and the dehydration of alcohol. There is two reactions are there. Here, simply the alcohols are converts to alkene. So this is dehydration of alcohol. Then, see the concentrated, usually when you use the concentrated sulfuric acid, it acts as a dehydrating agent. That is why this is because of dehydration of alcohol. The dehydration of alcohol gives alkene compound. Here, this is not alkene, just I am telling the general name, but this compound is ethene. See, the alcohols affect in living beings. Usually, when large quantities of ethanol are consumed, it tends to slow metabolic process and to depress the central nervous system. So, this results in lack of coordination, mental confusion, then lowering the normal inhibition and finally stupor. So that the individual may feel relaxed but does not realize that is his sense of judgment. Sense of timing and muscular coordination have been seriously impaired. So, unlike the ethanol, that is alcohol, intake of methanol is very small quantity, can cause death also, because the methanol is oxidized to methanol, that is converts to aldehyde. in the liver. So methanol reacts with rapidly the compounds of cell. It causes the protoplasm to get coagulated. In much the same way an egg is coagulated by cooking, the methanol also affect the optic nerve. Usually suppose if you take methanol, the small quantity of methanol first will affect, that is you will get a blindness. Then the ethanol is an important industrial solvent also. The prevent of the misuse of ethanol produced for industrial use, it is made unfit for drinking by adding the poisonous substance like methanol to it. Okay, dyes are also added to color the alcohol blue so that it can be identified easily. That is why these are called denatured alcohol. Then usually the alcohol as a fuel, the sugarcane plants are one of the most efficient converter of sunlight into the chemical energy. So sugarcane juice can be used for prepare molasses which fermented to give the alcohol, that is ethanol. So some countries now use the alcohol and additive in the petrol, since it is a cleaner fuel with the gives rise to only the carbon dioxide and water on burning the sufficient air, that is in oxygen. Next we will see the properties of the ethanoic acid. See, next is the properties of the acetic acid or ethanoic acid. The ethanoic acid the commonly called as acetic acid, and the belongs to the groups of that acid is called carboxylic acid. Then the 5 to 8% solution of acetic acid in water is called vinegar, that is we are used in the preservatives. So here the melting point of the pure ethanoic acid is 290 Kelvin. So usually they are freezes in winters. Generally the pure melting point is 290 Kelvin. Then the group of the organic compound like called carboxylic acid is obviously characterized by the special acidity. So however, unlike the mineral acid like HCl, which are comparatively, that is completely ionized compared to the carboxylic acid, because the carboxylic acid, see HCl undergoes the complete ionization. This is aqueous HCl. It undergoes the complete ionization process. But in acetic acid, in the case of the acetic acid, if you take acetic acid, it undergoes the partial ionization because the H plus and the CH3 COO minus. Here the complete hydrogen transfer, but here the partial hydrogen transfer. That is why the acetic acid is weak acid. Okay. Then next is the esterification reaction. Esterification reaction means the acetic acid when react with alcohol, that is absolute alcohol, pure alcohol, in the presence of the acid catalyst. Acid you can write like this H plus also, it gives a ester. This is ethyl ethanoate. The esters are usually sweet smelling. Here you can use it, the perfume industries also. Then the ester treatment with base will get the alcohol and the sodium acetate. So this reaction name is called esterification reaction. Then the reaction with base, when the sodium hydroxide treatment with the acetic acid to produce sodium acetate and water. This is sodium acetate. When react with reaction of carbonate and the hydrogen carbonate. When the acetic acid react with the sodium carbonate, this is the carbonate substance, to produce the sodium acetate and water, then the carbon dioxide gas is evolved. Similarly, react with the hydrogen carbonate, that is acetic acid react with sodium hydrogen carbonate to produce sodium acetate in water, then the carbon dioxide is produced. Both the reaction produce the carbon dioxide gas. So this is the properties of the ethanoic acid. Next is the soap and detergents. You know that the soap and the detergent, that soap contain the long chain fatty acid with sodium or potassium salt. See, we'll see that how the cleansing actions takes place. Usually, suppose if you take the distilled water in one test tube and another test tube normal water, that is tap water, groundwater or tap water. Just add some soap oil, shake vigorously. What happened? That the distilled water gives a more foams than groundwater, because of there is no ions are present in the distilled water. Distilled water means there is demineralized water, but the groundwater contains some ions. It is groundwaters or in well water, tap water, whatever it is. This is demineralized or deionized water. So this having no ions, here no ions are present, but here some impurities like potassium, sodium salts are present. That's why they produce less number of foams, that is leathers. Here then the micelle formation. The soaps are usually the soap molecules are which two ends. They having a different properties. The one is called hydrophilic, that is dissolved in water, while the other end is called hydrophobic. So that is the dissolved in hydrocarbon. When soap is at the surface of water, the hydrophobic tail of soap will not be soluble in water, and the soap will align along the surface of water with the ionic end in water and the hydrocarbon tail, that is inside the water. So inside the water, these molecules having a unique orientation that keeps the hydrocarbon portion out of the water. So this is achieved by forming the cluster of molecules in which the hydrophobic tails are in interior of the cluster and the ionic ends are on the surface of the cluster. So this formation is called micelle formation. So soap in the form of the micelle is able to clean. Then the oily dirt will be collected in the center of the micelle. The micelle stays in the solution is a colloid and will not come out, that will not come together to precipitate because of ion-ion repulsion is there. So the dirt suspended in the micelle is also easily rinsed away. The soap micelles are large enough to scatter light. So hence the soap solution appears cloudy. See, have you ever observed while bathing that foam is formed with a difficulty and an insoluble substance like scum remains after washing with water? This is caused by the reaction of soap with the calcium and the magnesium salt, which cause the hardness of the water. Hence, you need to use the large amount of soap. This problem is overcome by using the another class of compounds called a detergent, and the detergent as a cleansing agent. So detergents are generally ammonium or the sulfonate salts of long chain carboxylic acid. So the charged ends of these compounds do not form insoluble precipitate with the calcium and magnesium ion in hot water, so that they remain effective in hot water. So detergents are usually used to make shampoos and the products of the cleaning clothes. See, the next reaction is the esterification reaction. The esterification reaction means what? Usually you know that the alcohol, that is I am having ethanol, glacial acetic acid and the concentrated sulfuric acid. See, I am going to do the experiment with the help of this solution. See, just I am going to take the small amount of alcohol, then add the glacial acetic acid. Just I am going to add drops of the glacial acetic acid, that is 1 ml. After that, just take concentrated sulfuric acid. Just I am going to add some concentrated sulfuric acid. After that, just heat the solution on heating you can observe that is smelling, sweet smell is, the sweet smell will come. You can see, but you cannot see the smell, you can feel that. If you do the reaction in the laboratory, just you can realize the experiment, that is the esterification reaction. That's mean it converts to what? Ester. When reaction of ethanoic acid and ethanol, it converts to ester. It is a sweet smelling substance. See, I can see, just heat few minutes, then easily you can get the you will now I can feel the sweet smell. Okay, so this is called esterification reaction. Then next is acetic acid, that is test with the litmus paper and the universal indicator. See students, this is universal indicator, dilute HCl, dilute hydrochloric acid, and this is the glacial dilute acetic acid. Now I am going to test with this help of the litmus paper and the universal indicator. Now I am going to take the solution, that is sulfuric dilute HCl in this test tube. Then and one more test tube. Just I am going to keep this test tube here, and one more test tube. I am going to take a glacial, that is acetic acid, diluted acetic acid. Now just I am going to check the solution whether it is acidic or the basic. This is a blue litmus paper. If the blue litmus paper turns in red, means that is acid in nature. Now, so the blue litmus changes to red. That means the first one, this is the dilute HCl, that is acidic in nature. Similarly, in this side, I am going to dip this solution. See, this is also changes to the red. Blue changes to red. Now I am going to, that means both are acid in nature, that is acidic in nature. Now I am going to add this universal indicator in the both test tube, HCl and the acetic acid test tube. And here also I am going to add some . See, look this, the both solution, the what is the intensity of the color? You can see the color intensity, that is the first one. See, the first one having the intense red color. Then look at this, the second one, this is glacial acetic acid, the universal indicator. Now can you see the difference of the color? See, this is more intense and this is the less intense. That means the more intense, you can see here the 0 is more intense, then the next is 1 is intense of the intensity is slightly decreases. Here the pH look at this, compare with this color, or you can use it the pH paper also. The pH paper also shows the different colors. See, you can see the intense, more intense indicate the strong acid, and this is the less intensity is indicates the weak acid. So here you can conclude the acetic acid is a weak acid and the HCl is a strong acid. Okay students, now you can see the color again, no changes. So that this is strong acid because this is complete ionization undergoes. When react with water, what happened? The dilute HCl, complete ionization undergoes. That means H plus is transferred completely and the Cl minus transfer completely. That means H plus and Cl minus dissociate completely. But here H plus and the remains in CH3 COO minus. That is partial ionization takes place. This HCl is complete ionization takes place. See students, the next experiment, just I am going to add, this is one test tube and this is A, test tube A, and this is test tube B. I will take the test tube on this side. Just I am adding water. See, the both test tube having the same quantity of the water. Now I am going to put a oil drop, that is vegetable oil, that is cooking oil. This is a cooking oil. Just adding the oil in both test tube. See, can you see this? Oil does not dissolve in water. You can see that. Now, this is test tube A. Imagine this is test tube A and this is test tube B. In test tube B, I am going to add small amount of the small drops of the soap oil. I am having the soap oil here. Just adding soap oil. Now, just shake vigorously in this test tube. Both test tube, shake vigorously. Just leave some time. What is the observation? See students, can you see this? The test tube A, only water and oil. Now the water and oils are separated. You can see here the oil and water are separated, but the test tube B having oil, water and soap solution. Now see, the water is down, but the soap solution and oil is mixed. That means usually the dirt are going out. That is because of the soap solution react with this, only the water is in the bottom of the test tube. Hi student, see, today we were seeing some activities also, that is ethanoic acid preparation, the properties of ethanoic acid and ethanol also we were seeing. Then soap and detergents also we were discussed in this session.